So this is my favorite chapters to cover. So it's basically Intro to Ecology, but it's a very gentle introduction to ecology. And it comes from chapters 45 and 46. So generally speaking, ecology itself, the term comes from the Greek word oikos, which means our home. So essentially, ecology is a study of our home, but it's also the study of groups of organisms and how they interact with each other and with the environment around them. So we talked at the beginning of the semester about the levels of biological organization. And so one of those levels that we referred to was a population. And so when you think about populations, you're looking at a group of organisms and they're going to be the same species and they're in the same region, right? Like when you go into a city, the city limit sign, you can see that there's a number, and that number pertains to those humans, we know it's humans, that are living inside that city limits, right? So that's a population. The community level of biological organization really looks at the interactions that are among two or more species. And at this point, you're still not really interacting with the environment. You're looking at how individuals interact with one another. And obviously, a really good example of that would be predator-prey relationships. Then when you look at the ecosystem level of biological organization, you're looking at the community of interacting organisms who are also interacting with their non-living or abiotic environment. And so if you look at this image, you can see that there are actually at least four different ecosystems that we can tell in this image. So there's the pond, obviously organisms that are living in the pond. They're not going to sustain themselves so well on the top of that mountain. Um, there's the forest. There's the meadow. All of those are different ecosystems with different individuals that can thrive there. Basically, the things that determine what organisms can sustain themselves in a certain ecosystem is really determined by the physical environment, so both living and non-living, as well as other organisms that live in the environment with it. So obviously, um, some living or biotic factors that impact where an organism can live and what kind of ecosystem they can choose include the effective species as food or predator. Do you have enough resources? Are you going to get eaten? Maybe even the soil, or if you're a plant, the passage of organisms. If you're a plant, you're not going to be able to sustain yourselves in that ecosystem if you're trying to thrive in a place where there's a lot of traffic. Non-living factors that determine where an organism can live include rainfall amount, duration, seasonality. So if you require a lot of water, you're going to only be able to sustain yourself in an ecosystem that has a lot of water. Temperature, if you're accustomed to icy cold temperatures, you're not going to be able to thrive in a tropical environment. Latitude, the amount of sun available, wind, even the slope impacts where an organism can live. So the term biome refers to a really large ecosystem, and they're characterized by specific plants and animals. So like when you think of the tropical rainforest, um, that's pretty common. You get an image of what you're looking at. Or if you watch Lion King, that's a pretty good idea of what the savanna of Africa looks like. And so biomes themselves are determined by rainfall amount. So does it get a little? Does it get a lot? And also temperature. So remember that when you think of a biome, think about the amount of rainfall you get and the temperature as well. So there are some major terrestrial land biomes. When you look at where a biome is, think about the temperature with regards to how close it is to that, how close it is to the equator, okay? And also think about a biome with regards to water amount. Like you know that if it's going to have a lot of trees, you're going to get a lot of water there. This is an example of some of the important biomes that we talk about. So the tropical rainforest, the savanna, temperate grassland, temperate deciduous forest, which is us, the tundra, the taiga. So first we'll cover the tropical rainforest. In the tropical rainforest, it's very warm. There's a ton of moisture. It's very wet. It's very layered. So you're going to see a high diversity of species here. And there are said to be organisms that live in the canopy of a tropical rainforest that have never left the canopy of that rainforest. Obviously, there's always issues with rainforests and clearing of rainforests. That is an issue. They clear it for farmland. They clear it for, just the lumber. 2 to 3 years later, it looks very sad. A tropical savanna is one of my favorites. So essentially, tropical savannas are dry tropical grasslands. So they have wet seasons and they have dry seasons, with wet being really wet and dry being really dry. They have some scattered trees and they have a lot of really open spaces, and it's warm. No, it's very close to the equator, and there's lots and lots of grasses here. The animals you might find there are herds of grazing animals like elephant, rhino, zebra, giraffe. Because of those large grazing animals, the savanna can actually support predators like lion and cheetah. The temperate grasslands have 4 seasons. It has limited rainfall and occasional trees. Then there's the deciduous forest, the temperate deciduous forest, and this is where we live. In the temperate deciduous forest, you would have leaves, so we have deciduous trees. We have moderate temperature, moderate rainfall. We have a ton of diversity. We have a pretty constant climate where we live. You'll find a lot of mammals. You'll find a lot of birds. The taiga is the cold coniferous forest. So in the taiga, you'll find that it's wet, but only in the summer, which is a very short summer. You'll find trees like spruce, pine, fir, the type of trees that keep their needles all year long. You'll find large mammal like elk, moose, deer, and the winters are very long and cold. Then you get to the Arctic tundra. So this is very dry. It is very cold. There is permafrost here, so there's a permanent layer of ice. It's got a low amount of diversity. It's very fragile, so if there's a change made in the tundra, it takes a long time to repair. You'll find small plants. You'll find musk oxen, caribou, reindeer, wolves, Santa. No, just kidding. The deserts are actually the fastest growing biome, and that's said to be because of climate change, most likely. Deserts have very low rainfall, so organisms that live in a desert have to have adaptations for dryness. They have daily extreme temperatures. It can be super hot or super cold. They have low diversity, and the critters that do live there are usually only active during rainy times, active at night, or else they have very good burrowing skills. This is a really cool layout of basically where each of the biomes fall in with regards to temperature and then also rainfall amount. So some of them are super extreme. The next chapter that we talk about really goes over, we've talked about ecosystems and we talked about how these guys work together, how organisms interact with one another and their environment. One of the most critical things for living organisms is their interactions with each other. And so a symbiotic relationship is really looking at the good, the neutral, and the bad interactions that organisms can have. So sometimes they can both benefit, sometimes one organism gains and the other one isn't really affected, and sometimes one organism gains and one actually loses. So in a symbiotic relationship that's called mutualism, everybody gains in this relationship. And the best example of a mutualistic relationship is, of course, um, the flower and its pollinator. So the flower wins by offering a nectar reward by luring its pollinator. The pollinator comes and visits, brushes some pollen on, and then carries that pollen to another plant. And so then we have genetic diversity because our pollen is going from one plant to the next. Commensalism is a symbiotic relationship where one individual gains from the relationship and one individual really isn't affected by that relationship. And so my best example of a really good commensalistic relationship would, of course, be Nemo, right? The clownfish and the sea anemone. I know, I watch too many kids shows. So um, in Finding Nemo, Nemo and his dad live in the sea anemone, and that's because the clownfish can hide within the sea anemone. The sea anemone has these little like barbs. They're like little spring-loaded harpoons that shoot out and sting. They're called cnidocytes, and they shoot out and they sting their prey. Only the clownfish have adaptations where they're not affected by the sea anemone, and so they can hide within there and get protection, but they're not doing anything beneficial or harmful for the sea anemone. Parasitism is probably my favorite just to talk about, not to actually experience. But in a parasitic relationship, one person is negatively affected and one person gains by that relationship. Like the mosquito in this image is definitely a parasite because it is taking your blood and you are left with an itchy boo-boo that you do not like. Parasitism, I mean, there are so many good parasites. You could spend hours and hours just talking about some of the best parasites. And a very, very good parasite does it in a way that it's not detected and in a way that it does not harm its host. That's tricky. Now, parasitism also is including, in this discussion, we include discussion on disease parasites, but also predator-prey relations as well. So if you're going to be an organism that is avoiding being somebody's prey, you have adaptations that will allow that to happen. So some adaptations to avoid predation include camouflage, be hidden, then maybe somebody won't eat you. That works really well. Mimicry, you can look like something bad even though you're not. So there are plenty of flies in this world that try to look like bees. There's box elder that tries to look like poison ivy, and we don't want that. Warning coloration, that's a really good one. Anytime you see something like very vivid in nature, understand that it takes a lot of energy to create that color, and understand it is a warning. Like if you're in a green forest and you see a very starkly distinct black and white skunk, you're gonna know that that's right there, and that's a warning. That's very striking in the woods. Even a ladybug has a warning. Ladybugs are a beetle that come from the Cocinellidae family, and so if you scare them, they actually release cocinellin, this acid, from all their little joints, and it kind of stings a little. Most people are like, oh my god, the ladybug bit me! However, their mandibles are way too small for that business, but they do release an acid from their joints, and it can kind of feel discomforting. Toxicity. Being toxic is a very good adaptation to avoid predation. All of these organisms are toxic. Being prickly is a really good way to avoid adaptation. Like, I don't want to eat any of these things. They're sharp and prickly, and they don't look appetizing, and they'll hurt. I like my snacks not to hurt. Being tough is a good way to avoid predation. So have a hard outer shell where it takes way too much energy to get you out of there to eat you. Somebody though once was like, you know what? I'm gonna eat that lobster. It's looking good. And they were right.